For today's lesson, we'll be graphing more quadratic functions. It's just an extension to what we did yesterday. So let's take a look at the first problem that we'll end up seeing. So on these problems, we might end up having to solve for y. So the first thing I would do is just get to y by itself. You got to subtract that x squared from both sides. So once you've done that, you've got your equation that you'll use. Y equals the opposite of x squared minus 6x plus 16. So from there, remember what we want to do first is to find that axis of symmetry. So the formula we're using is this, negative b over 2a. That's the axis of symmetry formula. And so we could take our b term, which is negative 6, and we take its opposite. So the opposite of negative 6 over 2 times a, which in this case is negative 1. So times by negative 1. So this makes 6 over negative 2, which just makes negative 3. So that is the axis of symmetry, negative 3. So right along negative 3, which is right in here, there's going to be an imaginary line that breaks our parabola into two equal pieces. So if I go ahead and draw that a little bit further, you can see that line there. And so from here, we're going to take that negative 3, and we need to find y. So y equals the opposite of negative 3 squared, and then minus 6 times by negative 3, and then plus 16. So remember what I said when we're trying to find this vertex, this y component of the vertex, these first two numbers should be opposite in sign, and they are, because it's the opposite of negative 3 squared, which is negative 9. Because negative 3 and negative 3 make a positive 9, but times by a negative, or the opposite of, makes negative 9. And then plus 18, and then plus the 16. So remember what I said, these two will always subtract. One will be double the other. So this gives me 9. 9 plus 16 leaves me with 25. So what I'm doing is I'm going over 3 spaces to the left. So my vertex is negative 325. So over 3 spaces to the left, and then up 25 spaces. So we gotta go all the way up here, and let's see here, this is 24, 25, 26, 27, yeah, so these are going by ones, so it's right here. So that's our point. So from there, now we can use the parent graph, and so this portion right here gives some information. Now again, some people get a little confused with this. And so if you are a little confused, you can always rely back onto this point right here. See, this is your y-intercept. It's your y-intercept when you set x equal to 0. See, what you've got is you've got the axis of symmetry, you've got the vertex, so you know that's the maximum point. So if you go to 16, so 16 is right here, and then you can put in a point opposite of that from the axis of symmetry, so 3 spaces this way, so you go 3 spaces this other way, and directly across from it, there's going to be another point. So you have an understanding about that graph is going to do something like this. It's going to be making a U-shaped graph going down, opening down, because it's a negative x squared. Well, here's how the parent graph works. If you plug in a 2 or a negative 2, plus or minus 2, you're always going to square that. Remember, you always get the same number, 4. But then you take its opposite, and that's how you go get a negative 4. And so what this means is all this stuff did right here is it moved the graph. It moved that vertex to this spot. And so if you use this portion of the parent graph, if I go over 2 spaces to the right or to the left, I'm going to go down 4. So I went over to the left, I go down 1, 2, 3, 4, and I put a dot right there. And I have another point exactly opposite that. And so again, if you plug in a 1 or a negative 1, and you square that, you get 1. But then you take its opposite, you get negative 1. And so we end up having a point from the vertex over 1, down 1 space. So it gives us just a better understanding of the graph. But again, once you find that vertex, you use the y-intercept, that can pretty much give you a good understanding about what that graph ends up looking like. The way they got these points is if you go over 3, watch this, if we go over 3 spaces to the right or to the left, we take its opposite, we end up at negative 9. So that's what they did here. If we go over 3, we go down 9, and we end up at those points. And so from there, you can draw a nice smooth curve through those points. So that's kind of what our graph's going to look like. Let's take a look at the next one. This one's not quite set up for us. We need to get these terms over to the other side. So I'm going to go ahead and move everything over. When you move things over, all they do is switch signs. So you have to add the 2x, you have to add the x, you have to subtract the 10. So you do the same thing over here, and you've got your equation. Y equals 2x squared plus x minus 10. And this is now what we want to go ahead and use to figure out what our graph ends up looking like. So we start with that axis of symmetry. Negative b, which is negative 1, over 2 times a, which is 2 in this case. So we end up with negative 1/4. Now this is going to be a little tough because we only have to go over 1/4 of a space. So it's not even a whole number. It's just a portion of a number. So we're really close to this y-axis. So somewhere right along this y-axis, pretty close to it, is going to be this axis of symmetry. And so if I plug in the negative 1/4 in for these x's, here's what I get. See, we're trying to solve for y now. 2 times by negative 1/4 squared. And then we have to go plus negative 1/4. And this all equal, or minus 10. And so when I square this number here, I square the 4, and square the 1, I end up with a negative 1, or actually a positive 1, over 16 times by 2, and then plus this negative 1/4, and then minus the 10. So we go ahead and do this work. You see these cancel out, and we end up with 8. So we've now got 1/8 minus 1/4 minus 10. Well, 1/8 minus 1/4, remember what I said, you're going to end up subtracting these, and if you look, one's going to be double the other. So if I multiply this by 2 over 2, I get 2/8. 1/8 minus 2/8 gives me negative 1/8 minus 10. So that ends up giving me, I have to add those two numbers because they are opposite or the same sign, so that gives me negative 10 and 1/8. So here's the vertex. That's the y value. Our x value was negative 1/4. So we're just going over a fourth and then down 10 and 1/8. So you're pretty close to this 10, pretty close to the y-axis. And then from there, again, just use this point right here, positive 10. That's your one of the points. Now this gives us something that's really close. So I know it looks like this, and it's going to end up going up. And so if I just use that parent graph, go right in here, y equals 2x squared. And we go ahead and plug in a number like 1, and you square it, or negative 1, and you square it. And you multiply by 2, you get 2. So what that tells me, if I go over 2, or 1 space, sorry, x is 1. So if I go over 1 space in the x, in the y, I'm going to go up 2. So over 1, I go up 1, 2. Do the same thing opposite of that. And if I go over 2 spaces, 4 is what you get when you square 2. Times by 2 makes 8. So I go up 8 over 2. Up 8 spaces. And so that brings me just about to this 2. The height of 2, that is. And then from there we've got some points to be able to sketch our graph. So let's take a look at the next one here. We've got a y minus 4x equals 1/2 x squared. So you're going to end up adding this 4x to both sides. So when I do that, here's our new equation. I'll write it right in here. Y equals 1/2 x squared plus 4x. So from that point, what we're going to do is negative b over 2a. So x equals the opposite of b, so negative 4 over 2 times by 1/2. Well, 2 times by 1/2 makes 1, so I'm left with negative 4 over 1, which is negative 4. Substitute that in for x and see what y is. 1/2 times by negative 4 squared plus 4 times by negative 4. So negative 4 squared is 16. Half of 16 is 8. And then over here we have plus 4 times negative 4 is negative 16. So it makes negative 8. That's your y value. So your vertex is negative 4 comma negative 8. So you're 4 to the left and then down 8 spaces. And then from there we just use that parent graph. Now the parent graph goes this way. Again, you can always start with that, what the y-intercept is, and you don't see a number being added to the x term, so it's right there at the origin. And there's another point opposite of this. So you go 4 spaces over here, and you've got an understanding about what it ends up looking like. So it's going to come down here, hit this, and then move back up. So it's going to be a little bit wider. But let's go ahead and just come up with a couple other points. So if I do 1/2 x squared, plug in a point like 1. Or negative 1. Positive 1 or negative 1, you square it, you get 1. Times by 1/2, you get 1/2. So what that means is if you go over one space, you only go up a half a space. It's kind of where I have it. See how that ends up matching? And if you plug in a 2, you square it, you get 4. 4 times by a half gives you 2. So over 2 spaces brings you up just 2. So you get a point there. Over 2, up 2. So you get a point there. So you have an understanding about what that graph looks like. Well, one more problem here. We've got to move some terms over. So move these two terms just by doing the opposite operation. So we're going to end up subtracting the 3x squared. Subtract the 8. We've got our equation. Y equals, write it in descending order, negative 3x squared plus 12x, and then a minus 8. So that axis of symmetry goes negative b, so negative 12, over 2 times by the a term, which is negative 3. So that makes negative 12 over negative 6, which is just 2. So 2 is the axis of symmetry, so it's right along this line right here, somewhere right along there. And I've got an understanding about what it looks like, too. It's going to end up opening down because of that negative 3x squared. Let's find out where on that axis the y value is. So negative 3 times by 2 squared plus 12 times by 2 minus 8. So we do some work there. 2 squared is 4. 4 times negative 3 makes negative 12. Plus, and then this makes 24. Minus 8. See, these will always subtract. So you know you're doing something right if they're subtracting here. And one's double the other. So 12 is the number. 12 minus 8 makes 4. So there it is. Y is 4. So 2 comma 4. That's where we have to go. Over 2, up 4. And then from there, we know it opens down. Now just look for that y-intercept. What's the y-intercept here? Right here. Here it is, negative 8. So if you go down 8 spaces, there's a point. And then you can carry it over straight across from this from this axis of symmetry. So you know the graph kind of curves, and it doesn't touch that y-axis until it gets to 8. And so it's kind of hard to draw because you had to draw a fairly steep parabola there. And so that's kind of what the general shape is going to look like. But we can come up with some more points by looking at that parent graph. Negative 3x squared. So if you plug in a 1, you square it. Or a negative 1, you square it, you still get the same number of 1. 1 times by negative 3 makes negative 3. So over 1 brings you down 3 spaces right there. Over 1 down 3 right there. See, then it matches what we had. If you go over 2 to the right or to the left, so negative 2 or positive 2, you square it, you get 4 times by negative 3 gives us negative 12. So over 2 brings us down 12 right to the 2 points that we had. And so we've got it, so it ends up matching. So those are the graphs that you'll end up seeing. We're going to also take a look at a couple of word problems that we use quadratics to solve. So that'll be in part 2.